I'm not too tired to go over this with you. So here is lesson 5.5. This is applications. This is going to be very, very, very similar to lesson 5.1, where we started with applying the formulas. So you're still going to use the same formulas, but now we're going to work backwards. We're going to have different things that we're solving for. So anyway, so that's what we're doing. Here we go. So we're going to deal with the half-life function, m of x equals c times 0.5 to the x over h. Now, the half-life of carbon-14, you have to know this, so you can't solve it, it's 5730. Now, it says, how old is a mummy that has lost 49% of its carbon-14? Now, we don't know what the carbon-14 that we started with was, and that's actually just fine. We don't need to know that. But we need to know how much we have left of it. So we're going to go 1 minus 49% equals 51%. So we're going to set this as we're now 51% of whatever we started with. We don't know what that is, but it's C. Okay, it's going to equal C times 0.5 to the x over 5730. Okay, now this is where I can tell some of you probably would get confused, so I need to pause for a moment and talk about this. The C does not matter, okay? Especially when we're dealing with half-life. We don't know what we started with. That's the whole point. When you deal with this in a scientific way, is that you have no idea how much carbon you started with. You do know, and you're trying to figure out how old this thing is, but you don't know how much it started with. But that's okay, because we know that it's lost 49%. And how we know this, I have no idea. I'm not scientific. I don't know how they figure this out, but they have it, okay? So we know we have 51% of whatever we started with. Whatever this answer would be is equal to what we started with times this. So it helps actually that we have it in both sides, because now we can cancel it out. But I just wanted to show that this is kind of a weird problem. You're going to have to follow this formula exactly. So moving on, now we can cancel out the C's because they occur on both sides. And then I have 0.15. Oh, okay, hold on. Now, I need to get the x out of the exponent, so I'm going to take the natural log of both sides because I'm trying to get the x out of the exponent. Anytime you have an x in the exponent, the best thing to do is to introduce logs right away so you can get it out of the exponent. So I take the natural log of both sides. Then I can move my x out of my exponent. Maybe. Where'd I go? I realized I ran out of room again. This happens a lot, that I run out of room and I don't know where to go. I have no idea why my video is totally paused right now. Come on. There we go. Okay, moving the x out of the exponent. Now natural log of 0.51 equals x over 5730, because I moved the entire exponent out, times the natural log of 0.5. Now I can divide both sides by the natural log of 0.5 to get rid of it, so that I'm trying to get my x alone. This is basic algebra, folks. They just have natural logs in there, all these other complex stuff. That should have a point in it, by the way, right there. Okay. And I ran out of room, so I'm going up. And I have natural log of 0.51 over the natural log of 0.5 equals x over 5730. Now to get that x alone, I can multiply by 5730. That's a multiplication, not a decimal. And I multiply by 5730. And I put it in a calculator. And I end up with x equals something. 5566. So this mummy is 5,566 years old. Okay. Now you're going to have an example. Do the exact same thing. Follow the same process. Okay. There's your answer. And we're continuing, perhaps. Here we go. All right. This problem took forever, just so that you know. So how long does it take $500 to triple if invested at 6% annually each compounding period? So I did all three of these, so just be aware of that I did all three of these. If you get bored after the second one and you know how to do it, you can fast forward a little bit. But annually, so when I talk about annually, the 6% is, so 6% is how it doubles, or how it compounds each year. So when I put this in a formula, to triple, so $500 triple is $1,500, 500 times 3. So the amount that I end up with is 1,500, and I started with 500 times 1 plus my rate is 0.06 to the t. I don't know what t is, so obviously we're going to introduce logs in a moment. But let's simplify first. Divide by 500, and I get 3 equals 1.06 to the t. Then I take the natural log of both sides. You can take the regular log too. You'll get the same answer. But I like natural logs. And natural log 3 equals the natural log, or t times the natural log 1.06. Divide by the natural log of 1.06 on both sides. And I end up, put it in calculator, and I end up with t equals 18.85 years. So that's how long it would take to triple. Now quarterly, now this is where it gets a little tricky, because I have to remember that I have to divide my, my interest rate by how many periods I'm doing it, and then I also have to multiply the time by that same number of periods. So I have 1.06 divided by 4, or 1 plus 0.06 divided by 4, to the 4t. Then I can divide by 500 on both sides, that first. And I'm also going to put 0.06 divided by 4 in a calculator. I end up with 1 plus 1.015 to the 4t. Now we natural log both sides. You see, it's the same process every time. Okay, nothing's changing. Then I have natural log of 3 equals 4t times natural log 1.015. Now I'm going to divide by 4 natural log 1.015. I think we're going to fast forward to through the next one, because I don't think we need to go over all of that again. Because I want t by itself, that's why I did 4. And I end up with t equals 18.45, I think. Yeah. Okay, so let's fast forward through daily. Daily, the only difference is that we're going to end up with divided by 365. Oh, look at that go. That was a really big number. And we continue there. Look at all that. I get t equals 8. Oh, we even pause. Okay. All right. Did we do your practice 2 yet? There's your practice 2. Okay, I'm going to pause for a moment. Okay, there's your practice problem. Quarterly, so you have to do it like we did the second time. And this is your total. So, and just like we did it, you should be able to do just fine on that one. Okay. And there's your solution. Example 3. Okay, this was an interesting problem. This is the amount P of ozone in the atmosphere is currently decaying exponentially at a continuous rate of 1/4%. That is, K equals negative 0.0025. How long will it take for half the ozone to disappear? So you want your half of it to be gone, not the whole thing, but half of it. But we don't know what it is. But we don't have to. That's the beautiful thing of this. Okay, we don't have to because, let me pause for a second. Notice I plugged everything into the formula, so the K became, this pretty much laid it out for me. There's K, and so P over 2. So now I can cancel out the P's because they're on both sides. And we'll continue. And I have, so 0.5 or 1/2 equals e to the negative 0.0025x. Now, this is one situation where it would not make sense to use the log. You want to use natural log because natural log of e cancels it out. So I take the natural log of both sides, and I end up with the natural log of 0.5 equals negative 0.0025x. I can divide by negative 0.0025, put it into a calculator, and I end up with x equals something. I don't remember what the answer was. It was big, 277 something. 277 and 0.26. Okay. Now you're going to do one of these on your own. There's, oh, I went really fast through that. Okay, sorry, I wanted to backtrack. I want to make sure you have, for your problem, you have enough time. Okay, there's your problem. So you can solve that using the same formula we just did, same process. And there's your solution. Oh, I went back, I guess, a couple of times. All right, anyway, we'll see you tomorrow.